Is the world a mirage crafted by our consciousness? Does the universe exist independently of our minds, or is it an expression of consciousness? For centuries, these questions have troubled philosophers, scientists, and thinkers, and by the dawn of the 20th century, quantum physicists had joined the fray, coming face to face with these perplexing issues. They did not set out to do so, but found themselves grappling with this problem as a result of their own experiments, which probed into the nature of light and matter at the subatomic level. Their findings had forced the issue into the spotlight, suggesting that consciousness played an active role in the universe. At the heart of the enigma was the discovery that the act of observation or conscious awareness itself plays a fundamental role in creating the reality we experience. This is not merely a philosophical musing, it is a conclusion drawn from a century of groundbreaking experiments and theoretical frameworks that have revolutionized our understanding of the physical world. To truly appreciate the profound implications of quantum physics, we must first journey back to the dawn of the 20th century, a time when classical physics still reigned supreme. The universe, as understood through the lens of Newtonian mechanics, was a clockwork mechanism, a realm of predictable cause and effect, where objects moved in predictable trajectories and the future unfolded with deterministic certainty. This comforting illusion of order, however, began to crumble as physicists peered deeper into the microcosm, probing the nature of light and the behavior of atoms. This world of the minuscule, the realm of electrons and quantum particles, was found to be a far cry from the deterministic billiard ball universe that Newtonian physics portrayed. Quantum physicists found themselves staring at a universe that was anything but solid. Their experiments had revealed a baffling duality. Light, it seemed, could behave both as a wave, spreading out like ripples on a pond, and as a particle, a discrete packet of energy. This wave-particle duality, as it came to be known, was just the tip of the iceberg, a harbinger of the quantum revolution that was about to unfold. The atom, once thought to be the indivisible building block of matter, was itself found to be a miniature solar system with electrons orbiting a central nucleus. But the rules governing the behavior of these subatomic particles were unlike anything encountered in the macroscopic world. Electrons, it turned out, did not orbit the nucleus like planets around a star. They were no longer objectively existing entities akin to miniature billiard balls. Instead, they were ghostly apparitions that seemed to exist in a cloud of probabilities, their positions and momenta governed by a strange new set of rules, the laws of quantum mechanics. This brings us to one of the most mind-bending concepts to emerge from the quantum realm, that of superposition. It is a principle that strikes at the very heart of our classical intuitions about reality. In the quantum world, particles do not exist in definite states. Instead, they exist in a superposition of states, a kind of blurry haze of possibilities. Imagine a coin spinning in the air. Before it lands, it is neither heads nor tails, but exists in a superposition of both possibilities. Similarly, a quantum particle, before it is observed, exists in a superposition of all its possible states. It can be in multiple places at once, spinning in opposite directions simultaneously, and even possess different energies at the same time. This inherent ambiguity, however, collapses upon observation. The very act of measuring a quantum particle, of interacting with it in a way that extracts information, forces it to choose one state out of the many possibilities, crystallizing it into our reality as a discrete object. This process, known as the collapse of the wave function, is one of the most perplexing and debated aspects of quantum mechanics. Does consciousness then play a role in shaping reality? Is the universe, as quantum physics seems to suggest, a vast canvas of potentialities waiting for consciousness to brush against it and bring forth a specific reality? Quantum physicists had found that electrons and other quantum particles were not objectively existing entities, akin to miniature billiard balls. Instead, they were ghostly apparitions, existing in a state of flux within a quantum superposition of states. Each particle existed in every possible state simultaneously, a reality that only crystallized upon observation. Werner Heisenberg, one of the key figures in quantum physics, once said, "If we want to describe what happens in an atomic event, we have to realize that the word happens can apply only to the observation, not to the state of affairs between two observations." The reason for this is that a quantum particle cannot be said to have a position in space until it is observed by a measuring device such as a bubble chamber, and ultimately by a physicist's conscious mind. Until it has been observed, an electron could be anywhere. It is not real in any definite physical sense, and by extension neither is the physical universe, since it is composed entirely of such particles. Quantum physics is saying that without conscious observers, matter could not exist physically, but would remain in a non-physical wave-like state. In essence, physicists had discovered that the act of observation by a conscious mind was what gave reality to the quantum world. This was an unsettling revelation. It challenged the principle of strong objectivity, which posited that the universe existed independently of consciousness and would still exist even if there were no conscious minds within it. Yet the experiments were clear. Without a conscious observer, matter remained in a superposition of probabilities within a probability wave. And within this probability wave, each particle existed simultaneously in every state that would be possible for it if it were physically materialized, which is to say that in some sense, quantum particles exist in more than one place at a time. In fact, each particle exists literally everywhere in the universe simultaneously, in a kind of spread out or wave-like fashion. But amongst those possible positions, some are more likely, more probable than others to become physically real when an observation is made. Each location in the wave function has a probability associated with it. In the quantum realm, certainty gives way to probability. Instead of particles following well-defined paths, their behavior is described by wave functions, which evolve over time, spreading out like ripples on a pond, encompassing a range of possibilities. It is only when we observe a quantum system that this wave function collapses, and the particle chooses a definite state. This collapse of the wave function, however, is not a smooth, continuous process. It is an instantaneous jump, a sudden transition from a realm of probabilities to a single definite outcome. The implications of this probabilistic view of reality are profound. It suggests that the universe is not a deterministic machine, but a realm of inherent uncertainty where many probable events are all equally valid. The future in this view is not preordained, but unfolds from a sea of possibilities shaped by the act of observation. This startling discovery shook the pioneering quantum physicists to their core and led to an intriguing conclusion. Every probable reality that can be expressed physically exists as a valid possibility. The role of consciousness in this process was undeniable, and despite the discomfort it caused within the scientific community, there was no escaping it. Our journey into the heart of quantum weirdness has led us to question some of our most fundamental assumptions about reality. We began by challenging the notion of a clockwork universe, a realm of predictable cause and effect, and found ourselves face to face with the probabilistic nature of quantum mechanics, where certainty gives way to a sea of possibilities. Now we must confront another deeply ingrained assumption, the idea of particles as solid, independent bits of matter. In the classical world, we are accustomed to thinking of objects as distinct entities, occupying a specific location in space and time. A ball, for example, is a ball, whether it's sitting on a table or flying through the air. But in the quantum realm, this clear-cut distinction begins to dissolve. Quantum particles, it turns out, are not like tiny billiard balls bouncing around in the void. They are more like fleeting ripples in a vast ocean of possibilities, their existence defined by their interactions with other particles and with the very fabric of space-time. As Werner Heisenberg, one of the pioneers of quantum mechanics, famously put it, atoms are not things. This is a profound departure from our everyday experience, and it requires a fundamental shift in perspective. While we intuitively think of objects as having a certain size and shape, occupying a definite volume of space, Quantum particles defy this classical intuition. They are often referred to as point particles because, according to our best theories, they have no spatial extent whatsoever. Imagine, for a moment, trying to picture an object with no width, no length, no height. It's a concept that seems to defy logic, yet this is the reality we encounter in the quantum realm. Subatomic particles, the very building blocks of matter, are not tiny spheres or cubes, but dimensionless points of interaction. Their existence defined not by their physical size, but by their energetic relationships. The ethereal nature of subatomic particles has profound implications for our understanding of matter itself. If the fundamental constituents of the universe are not solid objects, but dimensionless points of interaction, then what does it even mean for something to be material? Quantum physics seems to suggest that the solidity of the material world is an illusion, a consequence of the way our senses and brains interpret the underlying quantum reality. Our exploration of the quantum realm has taken us on a journey beyond the familiar world of solid objects and deterministic laws, leading us to a realm where particles exist in superpositions of states, where certainty gives way to probability, and where the act of observation plays a role in shaping reality. But quantum physics has even more mind-bending surprises in store, concepts that challenge us to expand our view of reality even further. One such concept is that of potentia, a term coined by Werner Heisenberg to describe a dimension of reality that lies beyond our everyday experience, a realm of pure possibility, where all potential outcomes exist in a latent or dormant form. Imagine for a moment a vast cosmic ocean, its surface calm and undisturbed. Beneath this apparent stillness lies a hidden depth, a realm of swirling currents and eddies, representing a multitude of possibilities waiting to manifest. This is the realm of potentia, a realm that is not bound by the constraints of space and time, where particles exist not as definite entities, but as waves of probability, each wave representing a different potential outcome, a different path that the universe could take. It is a realm where the past and future are not fixed, but exist as a spectrum of possibilities, constantly interacting and influencing each other. But how do these probable realities become physically manifest? The answer lies in the interaction between consciousness and the probability wave of a particle. When a consciousness engages with this wave, it collapses, and one of the particle's probable states becomes physically real. The renowned physicist John Wheeler, known for his work on black holes and quantum gravity, once made a profound remark. If we're ever going to find an element of nature that explains space and time, we surely have to find something that is deeper than space and time. Something that, itself, has no localization in space and time. Wheeler's insight was that the very fabric of space-time, the stage on which the cosmic drama unfolds, might not be fundamental, but might emerge from a deeper level of reality, a realm that transcends the limitations of our everyday experience. And he believed that this deeper level of reality might be intimately connected to consciousness, because, as we've seen, when a consciousness engages with the wave, one of its probable states becomes physically real, resulting in a distinct particle in a specific location, moving in a particular direction at a certain speed. Now, this may seem to approach the classical notion of discrete lumps of matter moving about in space, but quantum physics has even more surprises, for this is not the full quantum picture. As we delve deeper into the strange and wondrous quantum realm, we encounter the paradox of light. For centuries, scientists debated the nature of light. Was it a wave spreading out like ripples on a pond, or was it a stream of particles, tiny packets of energy traveling through space? Experiments seem to support both views, with photons sometimes acting as if they were little particles when observed, and at other times acting as if they were waves. This was a paradox from a classical or materialist point of view, since a discrete particle should never be able to act like a wave. Waves and particles are incompatible things. The resolution of this paradox would come not from choosing one side over the other, but from embracing the strange logic of quantum mechanics. Light, it turns out, is neither simply a wave nor simply a particle. It is both, and yet, in a sense, it is neither. This is the essence of wave-particle duality, one of the most perplexing and striking findings of quantum physics. Simply put, quantum particles are not just particles, they are also waves, even though that seems a logical impossibility, and they are both of these things at once, yet also something more. But how can something be both a wave and a particle, two seemingly contradictory concepts? This sounds paradoxical, and it is a paradox from a classical or materialist point of view. The answer lies in abandoning our classical intuitions and embracing a new way of thinking about reality, one where logic itself takes on a more fluid and paradoxical character. In the quantum realm, things are not always as they seem, and seemingly incompatible concepts can coexist. Their paradoxical nature, a reflection of the deep strangeness that lies at the heart of existence. Physicists were beginning to see particles not as solid little balls of matter, but as processes that have relationships and interactions with other processes. Sometimes the kind of relationship they have with other processes will make them seem as if they were classical particles, sometimes as if they were waves. Moreover, it was found that light could only be observed as either a particle or a wave at any given time, never as both simultaneously. We see light as a particle or wave depending on how we look at it, on what kind of relationship we have with it, and how we interact with it. Quantum particles are processes that have relationships and interactions with other processes, and when a scientist observes a quantum particle, they themselves become the other process that the particle comes into relationship with and interacts with. This is so because in quantum mechanical terms, we too are processes, since our bodies are composed entirely of quantum particles. If the equipment we are using is designed to look at particles, we will enter into that kind of relationship with the particle-wave duality that we call light, and it will appear to us as, and actually be, physically a particle. But if the equipment is designed to look at waves, we will enter into another kind of relationship with light, and it will be spread out in space and appear to us as, and actually be, in physical terms, a wave. There will be no particle in that case. Consciousness is needed to collapse the wave function, but we can also use our consciousness to determine how the wave function collapses just by altering the experimental setup. Quantum physicists were beginning to peel back the surface layers of physical reality and were finding some strange fish swimming there. They were beginning to glimpse the inner workings behind the actual construction of physical reality, and it was becoming apparent that consciousness played a role, and a central one at that, in the formation of physical reality. Light exists then as both a wave and a particle, but can only show one of its faces at any given time in physical reality. It is physically impossible for light to exist as both a wave and a particle at the same time. Physical reality imposes a limitation on light. It forces a choice, demanding that light be one thing or another. Light is something that can never be fully realized as itself within our physical universe, but only in a limited form, camouflaged as either a particle or a wave. Light, like all complementarities, is thus always something more than the sum of its parts. But what then is light like when it is not physical? What is this thing called light that can exist physically in one of two possible states, but exist prior to that in the state of potentia in some third state? Physicists cannot say what light is truly like. They only know that its definition must include the ability to exist physically as either a particle or a wave. To make sense of the paradoxical nature of light, and indeed of the quantum world in general, Niels Bohr, one of the founding fathers of quantum mechanics, introduced the concept of complementarity. This principle, rather than attempting to resolve contradictions, embraces them, suggesting that seemingly opposite aspects of reality can be complementary, each revealing a different facet of a deeper truth. Just as a coin can show either heads or tails, but never both simultaneously, yet both sides are necessary to fully describe the coin, so too can light exhibit either wave-like or particle-like behavior, depending on how we choose to observe it. Neither aspect alone tells the whole story. Both are necessary to begin to grasp the nature of light. Now let's add another layer of complexity to this scenario. Just as light dances between wave and particle, so too does matter. Instead of solid, well-defined objects, particles of matter, such as electrons and protons, possess a wave-like aspect governed by wave functions. These wave functions, however, are not physical waves like sound waves or water waves. They are waves of probability, spreading out through space and time, representing the potential for a particle to exist in a particular state. Imagine, for a moment, a spinning coin suspended in midair, its outcome uncertain until the moment it lands. Similarly, a quantum particle exists in a superposition of states, a kind of blurry haze of possibilities, until the act of observation forces it to collapse into a definite state. Like the coin landing on either heads or tails, the particle is a manifestation of the quantum field when observed. When we look at it, it is a particle, but when we're not looking, it exists as a wave. This brings us to the pivotal role of observation in quantum physics. The act of observing instantly collapses the entire wave into a particle. Now here comes the twist. The wave function, laden with probabilities, is essentially passive. It cannot stimulate action from within itself. It requires an agent to make a choice among its probabilities for the three-dimensional world to be formed. This agent is consciousness. Consciousness initiates the transformation of a non-physical probability wave into a physical particle. This idea is echoed by the likes of Max Planck, who regards consciousness as fundamental and matter as derivative from consciousness. Consciousness and matter and energy are deeply entwined with each other, and we are just beginning to see them in their true, uncamouflaged form as aspects of a larger complementarity that transcends both space and time. This complementarity may be termed inner reality and is our first tantalizing glimpse of the consciousness-based reality that we are proposing in this series of videos. As we explore the interconnected nature of the quantum realm, we are forced to confront another deeply held assumption, the solidity of matter. In our everyday experience, the world appears solid, substantial, composed of distinct objects that occupy space and time. But quantum mechanics challenges this perception, revealing that the term particle is something of a misnomer. This brings us to one of the most mind-boggling aspects of quantum physics. We intuitively think of objects as having a certain size and shape, occupying a definite volume of space, but quantum particles, according to our best theories, are dimensionless points, possessing no physical extent whatsoever. Even when an electron looks as if it is behaving as a particle, it isn't actually a particle. It is still a set of relationships that don't take up any space. Imagine for a moment an object with no width, no length, no height. It's a concept that seems to defy logic, yet this is the reality we encounter in the quantum realm, the very building blocks of matter. The particles that make up everything we see and touch are not tiny spheres or cubes, but dimensionless points of interaction. Their existence defined not by their physical size, but by their energetic relationships with the world around them. Physicists refer to these ethereal entities as point particles because they have no extension in any of the three spatial dimensions. Quantum particles have no width or height or length, none at all. They are dimensionless. At the subatomic level, the solid, massy objects of classical physics melt away into dimensionless sets of relationships. And these relationships do not exist in isolation. Remarkably, subatomic particles cannot even be said to have any meaning when considered on their own. They are more like flowing webs of interconnections with other things than like little balls of matter. Think of them like notes in a grand symphony, their individual existence gaining significance through their participation in a larger, harmonious whole. Or like chess pieces on a board, each piece, each particle deriving its meaning and function from its relationship with the others. Without the context of the game, the chess pieces, much like subatomic particles, are void of meaning. The universe then is like a grand and ever-changing chess game, where subatomic particles are not independent entities, but interconnections among other particles. In the words of physicist Fritjof Capra, subatomic particles are not things, but interconnections among things, and these, in turn, are interconnections among other things, and so on. In quantum theory, we never end up with any things. We always deal with interconnections. The ghostly nature of subatomic particles has profound implications for our understanding of matter itself. If the fundamental constituents of the universe are not solid objects but dimensionless points of interaction, then what does it even mean for something to be material? Quantum mechanics suggests that the solidity of the material world is an illusion, a consequence of the way our senses and brains interpret the underlying quantum reality. At its core, the universe is far more akin to a vast thought than to a collection of discrete solid objects. Our exploration of quantum physics has taken us on an extraordinary journey, leading us far beyond the familiar world of classical physics, where objects behave predictably and the future unfolds with deterministic certainty. We have ventured into the heart of the quantum realm, a realm where particles exist in superpositions of states, where certainty gives way to a sea of possibilities, and where the act of perception plays a crucial role in the formation of reality. Along this path, we have confronted some of the most mind-bending concepts in all of science, concepts that challenge our very understanding of what it means for something to exist. We have seen that particles, far from being independent entities, are better understood as interconnected nodes in a vast web of relationships. We have discovered that the solidity of matter is an illusion, a consequence of the way our senses interpret the underlying quantum reality, where particles are not solid objects but dimensionless points of interaction, their existence defined not by their physical size but by their energetic relationships. The 5 axioms of materialism have all broken down by this point because they are based on something that does not exist. Irreducible material particles that behave in a deterministic fashion. That something does exist is undeniable, but it is not based on the classical concept of matter. The interconnections and relationships that exist between subatomic particles are not physical in nature. They are not material bonds that can be pointed to physically. They are more like mental or psychological states. At root, the universe is mental in nature, not physical, and if we are to have any hope of understanding reality or ourselves, we must shift our attention from the study of matter to consciousness. The universe is not a cold, indifferent machine, but a dynamic, participatory reality shaped by consciousness. We're not separate from the universe, but deeply enmeshed within it, our thoughts, intentions, and observations shaping the reality we experience. The universe is not only stranger than we imagined, but stranger than we can imagine, a universe where consciousness itself holds the key to unlocking the deepest mysteries of existence. A new paradigm is emerging, one that recognizes the interconnectedness of all things, the probabilistic nature of reality, and the active role of consciousness in shaping the cosmos. This consciousness-based paradigm, still in its infancy, has the potential to revolutionize not only our understanding of the universe, but also our place within it. It invites us to move beyond the limitations of a purely materialistic worldview and embrace a more holistic, interconnected perspective, one that recognizes the deep interplay of mind and matter, of consciousness and the cosmos.